Looks like it did. All right. So for this week, you're going to notice week 4 out there, and there's a bunch of content inside of there. So hopefully you guys figured out your APIs, some things to play with. We're able to retrieve some information and some other pieces in there. Now we're going to play with some Python modules and some sets of Python modules that will allow us to pull some financial data back in so we can kind of crunch through that a little bit. So if you look at the overview this week, our goal is to have the NumPy, SciPy video. That's kind of what we're recording here today. There'll be a bunch of links that you guys can use as reference points when you get ready. This week, you guys will complete your first mini project and you'll have your first quiz come in there. All right. Due dates for those are set for Sunday night at midnight. Again, on the mini project, try to get that in if you can, or something happens, let me know ahead of time. So NumPy and SciPy are two packages that are typically used for scientific computing within Python. They provide multi-dimensional array objects, various derived objects, masked arrays, matrices, etc., and an assortment of routines for fast operations within arrays. So you can make them operate much faster than what you would have within lists or dictionaries. All right. So if you go down here and kind of look, what makes NumPy so fast, it's because it's vectorized code, fewer lines of code, and it's more Pythonic. And then who else uses NumPy? It's typically used with this ND array. And then a lot of other packages will end up using this. So you'll notice if you guys were using, for example, the baseball statistic one, it uses NumPy under the hood in order to calculate some of those statistics, or at least organize some of that data that comes in. So you'll kind of want to click through here to the quick start guide, and it's assuming that you have matplotlib installed. We will work with matplotlib here as well, which is the graphing software, so to speak, within Python. If you look at an array, you'll notice it looks like a list inside of a list, right? So in this array, you're going to have something that has 1, 0, 1, or 1, 0, 0, and then 0, 1, 2. And those are all kind of set up in a way that they're relational to each other, right? So the first axis has a length of 2, right? We can see that here on the X. And then the Y has a length of 3 going through here. So there's 2 lists inside of this overall list, and each one of those consists of 3, so that axis is 3. Now, whether it's X or Y, we don't know yet. We got to tell the system what that is, but it allows us to plot out information there. Okay. You're going to have some nice little functions that will work, or methods right off that array. So you can do a dot shape, and it would give you back the max rows and columns. You could get the size, and it would give you the total number of elements in there. This D type is important to use from time to time. It tells you what type the data is. So if you guys remember from Python, you have strings, you have integers, floating point integers, etc. This is going to tell you what type of data type that is inside of there. So if it's a 32-bit integer, a 16-bit, or even a float 64-bit. All right. So if we look at this example here, we would do something like import NumPy as MP. Now notice when we work with NumPy, this is the proper way to import NumPy. Okay, so when you guys use it in your projects, when you look online for code examples while you're playing with stuff, you're going to see this at the top of every one. So when you guys import it, what that does is instead of having to type NumPy here .arrange, you can just type NP down below. Okay. So we're going to set up a variable A, and A, we are going to set up an arrange of 15 and a reshape of 3 to 5. What that does is create this array down here down below. So we can see we have 15 total numbers, 0 to 14. That's where this 15 comes in. We have a 3 by 5 array. So we have 3, 1, 2, 3 lists, and then 5 numbers in each list. 1, 2, 3, 4, 5. All right. If we did a shape, we would get 3, 5, so that we would know that this was, again, 3 on this axis and 5 on this axis. In dim is going to tell us the total number there. Remember that dim is the dimensional array, so how many axes that we have going across. The D type, these are integer 64, and you can get the extra information here. So you can create these a couple different ways. You can either pass it a list, in which case it'll turn into an array. That's the most common way for us to use it. So A equals NP array, and then we pass in some list. That will allow us to do array things to it. And that's mostly how you guys are going to use it in this week's assignment, but you can go way, way beyond what we do in this class, right? NumPy is its own kit and caboodle. You can do a lot of stuff there. When you go to print
Jason,
it, yeah.
hey, when you go, can you go back to where you imported that as NP? Is
Yeah.
that like when I'm importing different modules, is the given it a shortened name like that, is that a best practice for everything, or is that specific to NumPy?
It's specific to certain packages. So NumPy usually uses it. SciPy would. Matplotlib will sometimes have its own import there as well. So it just depends on the package and what common practice is.
And that's just so when I call it, I don't have to type out the entire thing, right?
There's that, and there's a little bit of just keeping the code down. So a lot of times when you're using NumPy and SciPy, it might be on embedded controllers. And though it doesn't look like it, you're saving, 3 characters out of there. Well, if you do that multiple times within the project, that takes up kilobits of code, and you may only have kilobits of code available, kind of thing.
Okay, that makes sense.
So, okay. So there's your arrays. There's you print those, so you can do a range so that you can print those in special ways. You can do a reshape, just exactly what we did up above. Basic operations, if you need to be able to subtract something. So if we had this NumPy array here and we had another one with B, notice that B looks like this. If we said C is A minus B, we're going to see that 20, and then this 30 is going to subtract the 1 from there. This one is going to subtract the 2. This one is going to subtract the 3 and get 47 there. So there's a couple different ways you can manipulate those arrays. All right. You can index them and slice them very much like what you could do with lists and other sequences. So if you wanted to pull out, for example, this little chunk here, remember we use 2:5, and that gets us through a list, and that allows us to pull out a subsection of those. You could put those into its own little array down here. All right. I'm not going to cover all this because, again, we're not going to use all of it, but this is meant to be here as a reference guide on how you would utilize it. Okay. There's also the SciPy side. And so SciPy is yet another collection of resources. It actually utilizes NumPy as well under the hood. And this is a way for you to do additional mathematical algorithms or things like that. So if you guys are dealing with any kind of ciphers or cryptography or doing anything that requires mathematical algorithms of some sort, usually you're going to utilize SciPy in there somewhere as well. SciPy, we won't necessarily cover that in here. The goal is just to show you that there's 2 different packages. And again, SciPy will use NumPy under the hood. But if you were dealing with Fourier transforms or you were doing some advanced mathematical algorithms that I cannot begin to explain that I know because I don't, it would do this kind of stuff, right? If you are in mathematics or something like that, you're going to utilize that kind of stuff. Where you guys would use it the most is when we start using Matplotlib. And so I'll show you that here in a second on the NumPy side. So for example, if we come down here to the plotting side. Oh, where's the plotting?
Jason, I got a good question.
Yeah, go ahead.
So you have used the term module and packages, right? So are those terms used interchangeably, or they're 2 different things?
So your packages are just a collection of modules and or functions or classes rather that you could be using through there. They're not necessarily vice versa, right? You can write your own module that's not necessarily a package. A package refers to you being able to pip install it, meaning that it's through a package installer. So packages like NumPy and SciPy and Matplotlib, those are all going to be packages. And then when you import that module, you're bringing a portion of that package in. So you may not be bringing it all. Like here, we're just importing the full package. We might only import pieces of it. So in this SciPy one, we're only importing 2 pieces of it for this project, not the entire SciPy. Does that explain that a little better, or do I need to go further? Okay. Let's see here. There was a couple I wanted to show you. It's not fractals. Looks like they've changed up the website a little bit. Moore's law is not really what we're after. Give me a second here. Let's see. There we go. And so this one here, the absolute basics for beginners, that's usually the one that I kind of walk people through and go through there. You can follow those steps if you want to. What I want to get down to is where they actually show you the array. Create some matrices, random numbers. Okay, so here we would end up using a package called pandas, and we'll talk about pandas more, but this would allow you to take your array and actually spit it out like a CSV file. And that may be useful in some of your projects. If you need to pull a bunch of information in, you can pull it in via CSV. You can pull it into an array like this, where you have those same numbers all stored inside there. We'll talk more about a pandas frame where we actually use what's called a data frame. And then it's set up in this similar, almost Excel looking chart. So here's how we would actually plot arrays with Matplotlib. You would build an array, whatever this data may be. And again, you may consume this off of some package. But if you look at something like this, it's going to be 2, 1, 5, 7, 4, 6, and kind of bounce around. When we have that set up, we also need to install Matplotlib. And so Matplotlib is the package you'll use for plotting. You'll want to import just the pyplot portion of that. So matplotlib.pyplot as PLT. All right. And then once you get that pulled in, now you can do something like plt.plot A, which takes this array, and it's going to plot it really nice up here. If you want to see it, you actually have to run plt.show, and that will actually show it up on the screen. All right. If you want to adjust what that figure looks like, there's a bunch of different things that you can do to tweak it. You can do things like linear space, where you're telling them how much you want this to go on side to side, up and down. You could tell it which axes you want to plot in terms of X and Y, whether you want the line to be through there, the dots to be associated with the Ys, however you want to adjust it. You can also go in here and do 3D graphs and other types of graphing if it's relevant to your particular style. So that's really what we're going to play with here today, is taking this simple array like this, and we're going to use Matplotlib in order to do a plot, and then we always have to run show in order to show that plot. You guys will then also save that plot as a PNG file so that I can look through your pictures and it shows the nice charts where they're all graphed out. All right. Also in the content, you're going to see this one here, which will tell you some of the differences between NumPy and SciPy. So you'll want to review this before you take the quiz. That way you can kind of answer some questions going back and forth there. The quiz itself is open book, open notes. So it's not like you need to overly study, but you need to figure out those differences, right? That's the whole point of the quiz, is that from a knowledge perspective, you understand the differences between the two. There's also a package called Anaconda. And so Anaconda is really just an interpreter. If you guys have remember, when we went out and first set up everything in this class, we went out and picked Python, right? We went to Python's website and downloaded the interpreter, installed it, and then stood it up in PyCharm. Well, if you come in here to PyCharm and say we did just a new project up here. Oops, let's do this again here. You'll notice down here, you can pick what interpreter type you want. And one of those is called base conda. And you would actually need to install either full-blown Anaconda or mini conda. And what that is it's a package meant for doing data processing that has things like NumPy and SciPy already built into it. It has all the different packages you may use with AI and machine learning. It's all kind of pre-baked in there, and it has its own package system. So Anaconda is a really easy one to get, and you can download it to your machine if you want to play with it. We won't in this class. I'm just introducing it so you guys understand that if you were to use Python in, say, machine learning, AI, or really deep scientific projects, you're pretty much going to do that based off Conda. And it's just a collection of all the modules you would possibly need all in one place. All right. Matplotlib documentation. This is going to tell you how to do your plotting. So down here, we talked about matplotlib.pyplot, and you're going to import that as PLT. For example, here, you could do plt.plot, and you notice that we can just send it a list, right? So we could send it the array that we had before from NumPy, or we can send it a list. It'll consume either one of those. We can set the Y label to the text of some numbers. Notice how the Y label now has that text over here. We can set an X label, and then when you're all done, you do a PLT show, and you get this nice little graph. All right. Give it more numbers. If you put two subsets of numbers in there, you'll end up with two different graphs depending on how you tell it to show. So like here on the plot, we can tell it going up. We can do an X-axis, and we can also show that data in there. Okay. If you want to show sample, you can go through here. You can do triangles, squares, whatever you want to show and represent the information that you're looking for. Again, there's a lot of different ones. You guys are going to go through here and see all the different options. I believe in Mini Project 2, you basically make really fancy ones. You just need to go through here and find some stuff to make it look nice and fancy and super clean. For today, we're just going to get the basics to kind of show it what it looks like. All right. And that takes us to YFinance. YFinance is a Python package that's meant for dealing with Yahoo Finance. It allows you to grab ticker information, and then we could download, like, say, the last 5 days of a ticker coming through.
And this counts as the API?
This is the API you'll be using for the first two projects. Yep. So to get started, we need to have pip install YFinance. So because we're going to use this for Mini Project 1, before we actually start in the PyCharm, I'm going to bring up Mini Project 1. And so mini projects are going to look like this. You're just going to submit the link to your GitHub. You will not submit your project files here on Blackboard. All right. The project is going to use NumPy and Matplotlib in order to create 5 graphs that output as PNG files. Okay. Initial comments with your name, class, and project are at the top of your Python file. You're going to import packages that are used and make sure you do the proper import. So for example, NumPy is using what? You didn't memorize that? 30 seconds?
Pip install. Pixie?
How do you import NumPy?
Import NumPy as MP.
There you go.
NumPy as NP.
Import NumPy as NP. That's the proper way to import NumPy. How do you import Matplotlib?
As MPL.
Nope.
I don't think we're using everything from Matplotlib. We're using a particular module, right?
Yep. You're using PyPlot. So you're going to use this string here. Import matplotlib.pyplot as PLT.
Yeah.
Okay. So that would be what I'm checking for on your proper imports. If you guys use other packages, like when we do YFinance, it'll just be import YFinance, right?
Can you show that Matplotlib one more time, please?
Yeah. It's right here. And that's in the Matplotlib documentation link.
I saw that.
Cool.
I found one. I just want to make sure I found the right one.
So that's 5 points there. The next 20 points is using a API of your choice, and YFinance is fine. So if you go find another ticker, you know, if you have some other source, you could use it, or you just use YFinance, that's fine. Collect the closing price of 5 of your favorite stock tickers for the last 10 trading days. All right. So you'll notice the inflection in my voice in certain pieces in there, because that's usually where people mess up, right? So we always want the closing price. We want 5 of your favorite stocks, which means you should be producing 5. And we want your favorite tickers for the last 10 trading days. Does anybody do any stock market data?
I do a little bit of like trading on my own. Are you looking for actual individual stocks, or are you looking for just funds?
Stock tickers.
Okay, so individual. Yep. Okay.
Yep, stock tickers. And it can be whatever ones you want. The key that I'm looking for here is the last 10 trading days. So what was the last 10 trading days here? In other words, do we trade on
Monday to Friday?
6, 7, 8, 9, 10. So it's like
Trading starts at 8 to 4, right? Is that
Central Time?
I think it's the 27th.
Western, yep. So here's the problem. What are you seeing in here that's going to cause a problem?
Labor Day.
Labor Day, right?
26th.
There was no trading on Labor Day. So you have to make sure you go back far enough to get me 10 total trading days. Now, here's the thing. You're going to write your code in a way that it doesn't matter how many 10 days ago were, as long as it pulls 10 data points back, right? So don't hard code it and say, I want the stuff for the 8th, the 5th, the 4th, the 3rd, the 2nd, the 1, because when I go to grade this, it should grab the last 10 trading days no matter what. Make sense? Okay. You're going to store that information in a list that you will then convert to an array in NumPy. It's a very simple command to do that. Then you're going to plot those 5 graphs, and feel free to add as much information to those graphs as you like. For example, the title of the stock ticker would probably be a good idea. The price of what it is, the date of the 10 data points. That's the other kicker here, is that I need a minimum that it shows me 10 data points. So there should be 10 points on the screen that I can see for data. And that's important because sometimes when you pull this data, it doesn't give you the last and the first if you don't do it right. And therefore, you will only show me 8 data points instead of 10 data points. I need to make sure I see all 10 data points. You're going to save those graphs in a folder called charts. All right. You won't actually upload those images to your project folder. Therefore, your project, when I run it, it should execute and create those 5 pictures for me. Right. So if I do this 20 days from now, I'm going to end up with different pictures. That's why I don't want you uploading it. I'm going to run your program to grab those 5 tickers for the last 5 days. You may want to add that folder to the get ignore. Makes sense, right? Because if you add it to get ignore, it won't accidentally submit those up to your Git repository. And we'll cover all this, by the way. I'm just kind of giving you a highlight of what we're doing. There'll be a minimum of 5 commits on your project. So make sure that you commit often. Don't just hit commit at the end, because I'll see that. Like, it should be legitimate commits. So if you do some little piece of your project and it works, do a commit. Now go on to the next piece of the project. Every major, think of it this way. If your document died when you were writing a story for class, how often would you save? Should you save?
Well, autosave.
Right. But autosave does it how often?
Every time you type.
There you go. So the idea is after you get done with a stretch, I wouldn't say do a stretch and then commit, but somewhere to that degree. The idea being that if you do lots of little commits, you can always go back to the last commit. If you don't do commits, you're going to jump back to the last big major milestone that you did. So try to do as many commits as that makes sense. Don't type A and then commit and write your commit message. I typed A. Like, I say this, I've had students do it, so I have to announce it, make it out there. All right, your next 10 points are going to be that I'm checking out the main branch of your project. So if you choose to use multiple branches, which I won't cover in here, but I will be checking out the main branch. Be sure that you have your requirements.txt file, which contains all the packages that need to be installed. Please be sure it only installs the packages that need to be installed for your project, meaning that you've set up the pip environment, everything else that I've already showed you in PyCharm, and we'll cover it here again. If you don't, it takes me absolutely forever to grade these because you downloaded the entire Python packages of everything on your machine, not the stuff for this project. And so by project 5, it gets hairy, or 4 rather. And I'll show you how to do that with the file called pip freeze. And then the last 20 points, notice that's a big chunk, is you setting up your readme.md file, which will explain what the project is, how to install all the pip requirements, and how to execute the program itself. And you should be using the GitHub flavor of Markdown. All right. I even give you a template for that. Remember that? It's back there at the beginning of class. You can grab that template, copy and paste it in, fill in all the little places of information, you're done. All right. Again, 20 points. Like, you get an 80 if you don't do that piece. It seems simple, but people leave those chunks out, including like the requirements file they'll forget, or the README file they forget. That's literally a 70 on the assignment because you forgot 2 little pieces of information, but they're big pieces. All right. Anybody have any questions on this? Obviously, we're going to go over that and we'll actually get it started for you. All right. So what I recommend doing, just like we've done in the other ones, go out to your GitHub and do a new project. And remember that we're supposed to call our projects. We go back here, very top, we have mini projects, and we should be naming them in this format down here. So I would copy this down here, and in my new repository, I would paste it in. Now, obviously, don't use Jason Zeller for yours. Use your own name, right? Make sure you use your full first name and last name because it never fails. I get people with the same names in here, and then everything messes up. So make sure you do it exactly like this. Once you get this up there, then you want to change your README to yes. Go ahead and have it create one. Change your gitignore to Python. And the license you can leave empty. Okay. Now I got to add a number here because didn't clear out my stuff from last year. So let's go with it. And I'll hit create repository. And this all worked. Great. So now what I can do is go to my PyCharm. And if I go to project control from version or project from version control, click on my GitHub, I should be able to find that over here. And so let's see if I have that. There it is right there. So I'll hit clone. And this window. And we need to configure a Python interpreter down here at the bottom. So we're going to click on that. We're going to add new interpreter and add local interpreter. Make sure we're set up for virtual VMV 313. This all looks good. So we can just hit OK. On this Defender one, you can go ahead and hit exclude folders, which will end up prompting you for a administrative privileges like that. And then I'll pause here while it catches up, getting that all stood up. Anybody have any questions in there? And if I go too fast in this, slow me down.
Hey, Jason, where did you find I know I've seen it before, but where did you find where you just copied the format of the name, the mini project?
That's back here on a section at the top called mini projects, right under YouTube playlist.
Ah, okay.
And then down below, you'll have this piece here. And so while I'm here, I'm going to go ahead and copy and paste this chunk out because I'm going to need that at the top of my new file here in a minute.
Jason, before you do that, could you walk us through the process of pulling the projects to our local repository from the GUI itself? How did you pull that project from the GitHub to PyCharm?
So you have this repository set up here.
Correct.
And then inside PyCharm, you'll go to project from version control. And then you should have your GitHub already set up over here from last time. If you click on it, it'll show you all the projects associated with your GitHub account.
Did you hit new project or how did you get to this clone?
Project from version control.
Oh, okay, I see. Okay. And then GitHub. Yeah, I see that. Okay, and then hit create.
It should be a clone down here. You should be able to click on the one that you created and then hit clone.
Okay. Okay, cool.
Jason,
Right.
are you okay with us adding the requirements for the assignment into our README, or so I can kind of use it as a checklist to make sure I don't forget anything?
Yeah, I'll
Or
show you that because that's actually required in your file. Yep.
okay,
Yeah, very similar to what we did in 360.
And
Yep.
when we do the virtual environment, we create new, right?
Yes. Yep. And so you want to make sure that this down here says Python 313, mini project 1, Jason Zeller. It shouldn't have a 2, but that's because I already had one.
Mine doesn't say that. Mine says, sorry.
For some reason, when I'm trying to clone it, it says directory already exists and it's not empty. Why does it say
You
that?
must have already cloned that down or had a project named like that on your system. Just go into your, if you look here at this folder tree under Python projects, you probably have some mini project 1, blah, blah, blah. Just go in there in File Explorer and remove it.
Okay.
And then do that.
Oh, okay. I tried to clone it from a different. Okay, makes sense.
Yeah.
Yeah, I tried to clone it twice and then it created it once, and then next time I tried to do it, it's saying the directory already exists.
Gotcha.
Right, cool.
Yeah, mine only picks a folder on my computer and throws it there. I don't know where it's at. I mean, I see it there, but it's every time I made a project, it goes to a different folder.
Are you creating a new project?
Nope, project version control did that, and I put it in a random folder on my computer. It's like in C dot program file system 30. I just randomly put it there.
Yeah, the only thing I can think of is go in here and you can tell it your default project folder, which is here under project structure. That's like settings for this project, but you should be able to do it for the whole and tell it where you want it to be. Okay, so again, you want this down here. If for some reason this didn't show up, it's probably because you missed that whole configure tab at the beginning when it said configure a new one. It's easy to fix. You just click here, add new interpreter, add local, and go back through those steps again. But it should match the name of your project in this interpreter. And from there, we're going to go ahead and pop open a shell. And remember that this needs to say .venv to make sure that you're in the virtual environment. If this is missing, something's messed up. You're missing this virtual environment down here. All right. If I was to go in and pip install, it's going to install it to my computer, not to the project. So you're going to end up with all sorts of weirdness. So always make sure that this pops up on the left. If you did this down here and it still doesn't show up, click the X to close out, click the terminal again, and it should then bring you up with the terminal inside. Those are usually the first pain points when people are learning how to use that setup. Okay, so if we look at this, we're going to type in pip freeze. And what that does is give us a list of all the Python packages we have installed. And you'll notice nothing happens, right? It shouldn't happen because we just started a brand new Python interpreter. There should be no Python packages installed at this point. So we want to do a couple things. We're going to import, or I'm sorry, pip install NumPy. All right. And then we're going to pip install matplotlib. And that's going to go grab a bunch of other packages. And then the last one is pip install yfinance. Take a little bit to get those packages, as there's lots of little packages inside of there.
For some reason, mine is just hanging when I execute a pip install NumPy. It's not doing anything.
Do you have any other pop-ups in the background that are looking for permissions or anything?
Checking that. I have another project opened up. Could this be a problem? I'm gonna close out everything and try do it again.
So here, if we now type pip freeze, you'll see there's a giant list of all these Python packages that are installed and their version numbers. So this is why it's important to have that requirements file, is it one, tells me what packages are required for your project. Two, it tells me specifically what package I should be installing. So version 1.17. That way, when I go to run your code, I don't just do a pip install because it'll more likely be a new version and it may break your code. As long as I'm using your requirements, I can always recreate your project.
So Jason, are we just after we do the pip freeze, are we just copying that into the requirements text file then?
No, we're actually going to use a handy command to do that for us. So if we do freeze greater than requirements.text. And so what this will do is take everything that came out of pip freeze and send it to our requirements.text file. Make sure that you spell requirements correctly, because otherwise commands won't work. And uppercase, lowercase, all that kind of stuff matters when we're dealing with it. So if we hit enter, you'll notice nothing happens except up here, we now have our requirements file pop up and it's in red. So we need to click on the commit and we can actually say, let's add that one there. And we don't want to add any of this idea stuff. So that brings us back to our initial stuff, things that we should do in an initial project. We'll come back to our commit. We'll go to our get ignore, scroll all the way to the bottom, and we need to turn on the .idea, which says don't save any of our PyCharm stuff.
That's under idea, right?
Not under idea. It's
Or you type in that. Okay.
Yeah, this is, if you scroll down towards the bottom, you'll see a PyCharm section and you'll take that comment out. So it looks like this. So now if we go back to commit, you'll notice that all those other files will disappear and all you'll have is your requirements now. Okay. And we also want to have our get ignore options added. And then if we go to our README, let's go ahead and copy in our README. And that is in this GitHub mini projects, tips and tricks, the README template, and we can just copy this whole thing in. Like that. And so again, you'll come up here at the top, you'll change your name to whatever it may be, not my name, but your name, and then you'll end up filling all this information in once you're done. Okay. For now, you don't have to change anything because you're going to do, that'll be the last thing you do. That's why it's the last thing in the grading list. You'll get the whole project working, then you'll come back and edit your README to match your project. All right. So now that we have the structure set up, this is where we should probably go do our first commit. So we can come in here and we could type in something like initial project setup. Now, I'm going to tell you something kind of cool. If you remove this and you click this little weird icon right here, the AI assistant's going to go through the code that you wrote and write a nice little commit statement for you. So you can write something that you recognize, or if you don't want to, you can just click that icon and they're going to auto-generate something to put in here. It's kind of handy. We'll do a commit and push. And it may ask you this on the first time in your new project. I'm going to uncheck this properties because I use this with multiple different GitHub accounts. So if I set it globally, I'll have issues. And then I can set commit and push. Something like that. And then I need to push. And if all went well, you should see this 3 files committed. And then we should see pushed 1 commit to origin main. All right. Come back out here to your GitHub, do a refresh, and you'll notice this is all set up in the right way. Okay, so we have this README that we'll need to go edit. We have our requirements file that has all the Python packages in it. We have our get ignore, which has the idea unchecked so that we can actually ignore all of our program setup files, and everything's ready for us to start our project. Okay. Again, you'll want to come in here and fix your title project, it should be mini project 1, et cetera, as you fill it all out. Okay. So to get started in this project, we need to go ahead and create a Python file. So if we go to the top level directory, you can either click the plus sign or you can right click on this and go to new. Either way works. And we want Python file. And we can name this whatever we want. We're just going to call this main.py. So if we just type in main, it'll automatically add the Python extension. We do want to add this to our repository. And then at the top of this, we could go ahead and just copy in this initial comments kind of thing that we have, just this little small section right here at the top. Come on, like that. And then we will want to copy in probably those requirements like we talked about. So if you come in here, look at week 4 and your mini project 1, we can just copy this whole thing out. So we're going to say something like this. Come into here and just dump that in there. And when you dump it in, you'll need to go back and highlight all of it and make sure you comment that out so it doesn't break your code.
So are we adding that first bit where it's the name, the class, all that stuff to every file then?
No, just in mini project 1 and 2, when it's only 1 or 2 files, that's where you'll do it. Beyond that, I'm only worried about it in the README. Otherwise, you're going to have thousands of files before long.
Okay.
Yep, just here to start. And on these, we don't need 3, we just need 1. So we can fix that little compliance issue that it was yelling about. Okay. Let's see here. So that all looks good. You'll notice we're green. So we got a new file that's going to get uploaded. And now we can go ahead and start to work with our project.
How did you comment on real quick at the same time?
You can just highlight them all. And if you come up here to code and comment with line comment, or it's control / one or the other.
Okay. Thank you. Sorry.
No, that's no problem. All right. So we already got our first 5 points here with our initial comments, name, class, project at the top of the Py file. Boom, right there. All right. Obviously, I would need to fix this so that my name is Jason and not Jane Doe. Then it says the proper import of our package is used. Well, in our case, we need to at least have import yfinance, right? And if we go to yfinance documentation, we're going to have to learn how to use it. So it says do a pip install yfinance. We already did that. And then to get started, it's usually, where is the, here. So you'll see this project links and homepage. Then down here, where's that documentation page? Usually, there it is, right there. Okay. So here's a quick start on how to get everything going. So you'll notice that we import yfinance as YF. So we're going to want to do that same thing. And if we just copy everything off this first line, that's the beauty of copy and paste. We can do that right there. So this is the quote proper import of yfinance because they want you to do YF. And then we set this variable called dat, which is using the yfinance class. And we're going to use the ticker method in order to come through there, or the ticker class rather. You pass it in some simple text like MSFT. That's the Microsoft stock ticker. Okay. You come down here for one ticket symbol, we can look at all the interesting information that we can pull, right? So we have dat and we can pull dat.info for now. So let's do that. And we're going to put that inside of a nice little print statement so that we can see what we get back. Okay, so let's do this and let's go ahead and run this. Now to run this project, you can just click this little play button up here at the top and that'll go ahead and execute it. And you'll notice it gave us a nice bit of information back about that stock ticker. What did we find out about this particular result? What does it come back as?
Dictionary?
What's that?
Came back as a dictionary?
Yep, that's right. So we could use our pretty print in order to see that information a little easier. So we can do something like pretty print. And just like your APIs you guys were playing with, we can see all sorts of information come back about this particular stock ticker. So we could get the current ask price, we could get the ask size, the bid rate. We can see who the company officers are, and it's got all their information from the year they were born, the age, chairman names. Like we can build an entire portfolio based off just Microsoft with all this kind of data, right? Tons and tons of information we could pull out of info. The one we're kind of interested in is going to be this history. So let's take a look at history of a month here. So instead of dat info, let's look at dat history. See what we get back. And you'll notice that we got back the last 30 days of information here. And we have open, high, ... dividends and stock splits. All right. That ... means that there's more columns inside of our frame that came back. And in this case, you got back a pandas data frame is what's being printed out to the screen here. So it looks like CSV and all that, but we can see the different variables that come through. So if we actually set that back here as a variable, and let's call this last month, right? And in that last month, let's say we wanted to get all of the opens out of there. So how would we go about that? We know that last month is this little array, and we need to pull out the last X amount of days. So better than doing that instead of last month here, it'd just be 1 month, right? Let's go look up history and see what we can all do with history. So this is where you guys were supposed to be getting good with APIs, where you would know you would come and look at the what?
That.
The API reference. So anytime you guys are working with APIs, you want to go find the API reference document because that's going to tell you exactly how to use every single one of these commands. All right. So we're going to use the API reference, and we have our ticker class, and we can see all the extra things that we can add in the ticker class. We can also come down here to history, comes out of our tickers. And we should get options on the history. So history, we get proxies, etc. Here's our ticker. And we can see history metadata. We actually want to get the entire stock. So let's look at our tickers. Here's our stock. This is a price history class. That's not quite what we're looking for. We just want the history. So let's see if we can find the history in here. You can also use the search if they're good. So byfinance.ticker.history. There we go. And in that history, we can send in different data options through there. Let's look at the metadata. This actually isn't giving us the full details like it should be. All right, well, let's just try it, right? We have one mo, I don't know, how about 10 day? I don't know if that's right, but let's try it. Okay, so let's call this last 10. And then let's just pretty print last 10. And it looks like we got just that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What else do you notice about these dates? Specifically the issue that we were currently seeing.
It's on Labor Day.
Right, no, Labor Day is not here, right? 9/1 is missing. And therefore it went back and grabbed the last 10 days of all those prices. So now we have our first little bit of data. We have our last 10 days worth of data for this particular stock, Microsoft. All right, so we're a good chunk into collecting the closing price of 5 of our favorite stock tickers for the last 10 trading days. Well, we know what Microsoft is now. It's stored here. And so we could store this in a dictionary, or we could store this however we want. In this case, we may end up wanting to even pull multiple tickers and get their information and their history back. So if we wanted to pull multiple in this fashion, how would we go about that? Yes, Y Finance has a special way of doing that, but we could do that. Does anybody remember in 360? We had a list of tickers. How would we go through them?
What was the question again, Jason? Sorry.
Yep. If we have a list of tickers, how would we go through those?
You mean for loops?
For loop. Yep. So we could do something like my stocks equals, and then we could just set a list of tickers. So we could have something like MSFT. Does anybody know some other tickers that they like? And if you don't, you can come out here to Yahoo Finance, and you could type in a search to figure out what their stock ticker is. All right. So if we look here, there's NVIDIA, we've got Berkshire, there's all sorts of stickers. We can also see all the top gainers right now if you wanted to. So for example, there's NVIDIA. We could pull its information, that's NVDA. So let's add that to our list. You can see Apple in there, so AAPL, NVDA. Anybody else got a favorite one?
Google.
BATRA.
What was it?
BATRA. It's the Atlanta Braves. They're publicly traded.
Gotcha. And we need,
AMC.
What
is
about
also
Google?
one.
okay, what's Google's?
It's GOOL, something like that. Let me get it.
There's actually several for Google. So you got Goog, and then if you're going to do their different equity packages that are in there, but they're now Alphabet Inc., right? So GOOG is their current one.
GOOG.
Yep.
We can do Tesla, TSLA.
What was it?
TSLA.
Oh, for Tesla? Yep.
Tesla.
So you guys can put whatever you want here in your code. Doesn't matter, right? I just want your 5 favorite ones. These are just some examples of ones that are in here. Now, how would we iterate through each one of those?
For loops.
For loops, right? And so what would that look like? For
Item.
something like that.
Yeah. Stocks in my stocks.
Right? And we could just for now print stock, and that should grab this here and then just print that out. That's not really what we want. We would actually want to do everything that we see here, right? So if we just take that and indent that, now it's going to take that stock ticker here and we're going to put in stock. Now it's going to loop through here, grab all that information, and then pretty print out the last 10 days for each one of our stocks. So let's make sure that works. Yep, looks like it worked. So now we at least got it the last 10 days for each one of our stocks, and we have a nice little for loop in order to pull that in. Okay. Well, we need to do something with that. We obviously don't want to print that data, right? We probably want to do something with it. So we could call, for now, we could do something like my stock data equals something like a dictionary. And we would put in the stock that comes in, and then we would put the value of whatever comes out of that. So let's do something like this. We got to define this up here. And then down here, instead of pretty printing it, we could do something like my stock data, exactly what that's doing there, right? And notice it pulled close. We could pull open, we could pull high, dividends, whatever piece we want, but we actually care about close, right? So let's grab the close for each one of those. And that's going to create this nice little dictionary of that. And then at the very end, we're going to do a pretty print of our data to see what happens. There you go. And so now we have the key is set to our stock name and the value is set to just the price of those 10 closing days. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. These are also date timestamps. So you not only have a price, you also have a date timestamp inside of there. So you've got time series data, which is nice to be able to kind of print that out and see what's coming out of there. All right, and it looks like all of these pulled back 10, so we're safe there. Sometimes you'll get ones that don't have 10, and then that obviously wouldn't work very well when I run the project. So we got our 10. Cool. So we are at the point where we have collected the closing price of 5 of our favorite stock tickers for the last 10 trading days. So at this point, you already got 30 points of your project done. Anybody have any questions of what we've got so far?
I'm a little confused on the date timestamp you're talking about. Like what? I mean, I see the 4 o'clock, but that format's just weird to me.
Yeah, so this here is just a date timestamp where you have the date, and then you have the time that came through, and then you have the price of whatever that was at that point in time. This is part of a pandas frame, so you got that portion of the frame. If you look at this type, you can see what that information is coming out. So it's a float integer over here, and that these are all time series data that came out of this Y Finance package. If you go to the Y Finance package and look at the stock tickers back here on the advanced, that's not what I want, the main package there. You can note that you can actually download this data if you choose to for each one of those. You can do some caching, some price repair. It's not really what I'm after, this part here. Yeah, see, a lot of times you can do these little functions and you can pass in the different variables as needed. But the return here, if we go and look at that history, said the result return is going to be a pandas data frame. And so I just have to find it in here, but that's what it will tell you it ends up being. There's history. And it comes back as a pandas data frame. Again, we're not looking to dive into pandas so much this week. Just know that you essentially have a list of all those pricing. And so here we say store this information in a list that you will convert to an array and NumPy array. So we didn't quite do that. We stored it in a dictionary, right? So let's do this because we need to store that as a list before we add it to the stock price. So what we want to do is take this part here, which is our data frame, and we need to add that to some kind of list. So again, with the for loop that we did before, we could say something like for price in the last 10 closing price. We can add that price as our stock in there, right? And that wouldn't actually work because that's just going to do that once as we go through there. And so what we want to do is add that to a list that's in here. So does anybody remember how we add things to a list?
No.
You said how to add to a list?
Yeah.
Isn't it a function with add?
It's not add.
Append?
Append, yep.
Okay.
So we would come in here. This is going to set our stock price to an empty list. And then we want to add that to that list, right? So we're going to say something like whatever our stock is, dot append, and we're going to append our price in there. Now that gets rid of our days at this point because we're just going to get the price information out of here. We don't know how to work with all that date series data like what you're seeing down here. So if we just do this, we're just going to get back the pricing, which is all we're supposed to get in this first week. So let's remove this. And then at this point, we can look at my stock data and we should end up with 3 keys and then end up being, or 5 keys with 5 individual lists. That looks better. So now we get Apple as our key and our value is going to be this list with 10 closing prices going through there. Okay. Now we're supposed to take that list and convert it over to a NumPy array. So if we go back to our NumPy documentation, and does anybody see on this quick start, how do we create an array from a list? Right here, right? So we import NumPy as NP. So we need to do that. Again, always do your imports at the top. Then we're going to steal a line that looks like this. And that can be down here where my stock equals a NumPy array of whatever this value is coming across here. So we could set up a list and we could pull that and go that down through there. We're going to do that so that we pull each one. So we stored it in that data, but we don't actually want to do anything with this data. It's just for our own reference. In this case, we're going to do something like my stock equals NP array. And inside that, we're going to take our list, and our list is our my stock data. This right here, I'm just going to copy it out. I have to do that like that. And so what that does is it converts this from a list to an array, and this my stock is now just a simple NumPy array. So if we want to check that, we could just print that for the time being to see what that looks like. My stock, and what we should get out is a little NumPy array, just like that. All right. We know they're NumPy arrays by the way they printed here, because you'll notice that they're got these blocks in here and they're not comma driven, that kind of thing. This is how it prints out an array versus a list. If we do this before we create that, for example, if we print this, which is our actual list, you'll see we get an actual list back with commas and separating the values in there. So an array doesn't have commas in it. And that's how you can make sure that you're getting the right output. Looks something like that. Kind of make sense? Okay. So we now have our stock into a variable here called my stock. And we may want to find better names for it, but that's just what I'm calling it for the time being. Then once I have that, I need to be able to plot those as graphs, and we need to add as much information as we feel like for those individual graphs. All right. At a minimum, it needs to show those full 10 data points. So let's go look at matplotlib. And it's very basic. We need to grab this import. We're going to put this up here at the top. And then we're just going to copy this because it's some very basic way of doing the plotting. And so we don't want to plot that list. We want to plot our list. So this will be my stock. On our Y label, we could say it's some numbers for now. We're actually going to see what it prints out because we may want to set that name correctly. And then we run PLT show so that it actually shows us on the screen what we did. So if we hit run, you'll notice that it generated a bunch of graphs off here off to the right. And there should have been 5 of them. And we can see what's over there. Now notice some number is not really some numbers, it's our what? What does
Price.
this? Yeah, our closing price specifically, right?
Closing price.
So let's set this to closing price. And if we rerun it, you'll notice that now we got closing price on the right side. And what's this bottom part represent?
Days, last 10 days.
The last 10 days, right? So what we want to do is just get rid of these over here. Okay. Let's set our X label. So PLT dot X label. And that is something like that. Or trading days ago, we could do something that way, whatever you decide to do. Now, if I run that, what's the problem with trading days ago? So if I look at this graph, and this is trading days ago, 0 days ago, it was something, right? All the way up to kind of a 9 over here. What's the problem with starting at 0 and 9?
They're going to be reversed.
Yeah, and we actually want to possibly reverse it, right? Because we want 10 days ago and moving off to the right, or we could go this direction, but that's just it. We don't know what direction it wants, right? We also start at 0. Should we be starting at 0? Probably not, right? We should start at 1 day ago, because if we look at our data, it was spitting it out as 1 day ago, which we could come back up here and look again. If we look at, let's just print our price up here. Yeah, you can see that those are the prices. We actually want the date inside of there as well. Let's do this. We're just going to grab those last 10 closed. Did that just give me close? Yeah, so if we look at what comes back in numbers wise here, let's look at this last one at the bottom here. And that last one should match to here. And you'll notice we start at 207, right? And 207 was 826. So you're right, that data is reversed. We actually want the 0 day or 1 day ago to correspond back here to 99. Okay, so what I'm getting at is we need to set these X labels so that with this actually matches with what we're looking for. So if we scroll down here, we'll see what we can do. And this allows us to format it, and you can see that we can plot these out. We can also set the axes to be what we want it to. So the way axes works, if we click on it, you set your X min, your X max, your Y min, and your Y max. And that's what you're going to pass in on the axis side. So let's go do that. Back here for our X label, let's do our PLT.axes. And we want to have something like X min is going to be 0, 10. And our next set is our Y, in which case this could vary, right, between these different tickers. So we might want to, we could either do some magic to go figure out what that would be, but you'll notice like this stock is down in the 40s and doesn't move much. 100s, 200s, something like that. So for the sake of this, we're going to hard code it now. Let's do 0. And it looks like the high end is maybe 1,000. Okay, let's see what those look like. What do we get here? I grabbed the wrong one. Oh, it needs to be in a tuple format. So we pass in a tuple. And if you remember, what's the difference between a list and a tuple? Anybody remember?
Nope, I'm taking notes on a sheet.
List you can make changes, but tuple you cannot make changes, something like that.
That's 100% correct. Good work. So a list is immutable, meaning we can mutate it, right? So mutable means a list is that we can change it, and a tuple is immutable, means that we can't change it. So we use it for things like this that are hard-coded data. We're not going to change the X, Y axes. It should be this kind of thing. So let's run that. It still doesn't like it. Why doesn't it like it? That would be weird to use those numbers. Let's try that. So instead of 6, this should be 10. Oh, anybody see what I was doing wrong? Notice what it is here. The correct answer looks something like this.
Remove the quote, single quote.
Yeah, the single quotes, we're turning it into a what?
String.
A string, right? And this wants you to actually pass it in with
Integer.
integers or floats in this case. If we actually look at its requirements right here on the screen, it wants you to be able to pass in floats. So that'll work too. Let's do something like a 10, 0, and then let's go up to that 1,000 for now. Get rid of those. Let's try this again. There we go. So it's not going to look as dramatic because we're setting that for every single graph. So in this case, instead of setting those last ones, let's just set the x-axis and let the y auto create. And it's not going to do that. So anybody got any ideas on how we can fix that?
So what's the issue here, Jason? I'm trying to understand.
Yeah, so the idea here is that we're trying to get this to show 10, which we got, right? But we're now looking with a closing price. And because these closing prices vary between all 5 of our stocks, we're getting this little fine line here where if we change this axis to something that was a little tighter in here, then we would actually see a much larger graph, a more meaningful graph.
Yeah.
So if you were to solve this problem, what would you do? Even if you don't know how to do it, what would you do?
You would want those the axis numbers to change per ticker, wouldn't you?
Yeah, yep. And what would we be looking for specifically so that we see a lot of variance in that graph?
You would want the high and low per stock.
Yep, great. So we need to figure out what the high number is and what the low number is within that series of data. So if you remember, we have our list, right? And our list looks something like, let's get rid of this close here. We have this my stock, right? And that's our list. Let's just print that out for the time being. I'm just going to show it here on the screen. Let's comment this out for now. Okay, so we got our little arrays and we need to figure out what the high one is and what the low one is out of each one of these, right? Well, the good thing is with NumPy, well, if we didn't have NumPy, how would you guys go about doing that? You guys remember? From 360?
Even there's a reverse thing.
Yeah, you could do reverse or you could do sort, right? If you sort them, that would get you your highest and lowest in that regard. So let's use that, but NumPy does have a specific way of pulling that out if you chose to use it. That's one of its nice variables. But for us, all we have to do is say something like my stock equals, it's actually dot sort, right? Just like that. Now here's the problem. If we do this before we actually print the data, we're going to have a problem, right? because then we just sorted our our closing prices and the graphs are always going to go up. And while we would love that to be reality, that's not reality. So we need to copy that list into another list so that we could then manipulate the other list. Does anybody remember how to do that? It's like 360 recursor day, right?
It's been a year.
So we could use copy.copy of my stock, and we'd actually have to import copy up here. Right. And then with that, we're going to do something like, we'll call it HL for high-low. And so now we have this other ticker here that will do that. We could do HL.sort. And then let's just print that. Let's print my stock, and then let's print HL so that we can make sure we didn't mess up our data. And we can see that. So it's going to print the stock, and then it should print out HL when it sorts through there. And it looks like it just copied it because it kept the same data structure. So that's fine because we're just getting doubles of each one, which we should. So let's make sure that that's accurate. And let's take HL and let's do, actually you got the dot sort, that's fine. Why did we not print HL? Let's do it this way. Well, you know why? Because we already converted it to an array. Let's do it before we create the array. So let's grab this. Let's do a copy of that. There we go. That looks better. Now we've got a nice little list, and it's going to give us the low price in that range and the high price in that range, right? That looks good. So we have HL, which will help us get the sorted out there. And we could put comments in here so we know what we're doing, right? So let's put some nice little comments in here. Something like create variable to determine high and low in time period. That looks good. And here we'll get our stock ticker. And this will be something like that. Okay, so what are we going to do with HL? Turn this back on.
It's x-axis, right?
X-axis we're going to leave as 0 to 10 because we know we're just covering the last 10 days.
That'll be y-axis.
Yep. So we could do something like HL what? Autocomplete is really doing my job for me here. I can't. So yeah, technically you could do this min-max, right? Does anybody remember the other way of doing that? How do you get the first, because you'll remember this is already sorted for us. So how do we get this first one out of here?
Bracket 0.
Yep. And so now it's already seen what we're doing there, which is we could do 0, which pulls the first one, and then the last one
And
was pulled with negative.
and the
Yep.
-1 or
Yep, -1 would do it there. So you could do it either way. You could use HL min max, or you can use 0, -1. Either way, it's automatically calculated. The benefit of doing HL min max is it has the ability of doing that without actually having to sort it, right? So we don't even have to create this. We could just go back and say, give me the min and the max. So if I wanted to do something like that, I would say, give me this stock and just give me the min and the max of that stock. And now I don't even need to create this. Let's try that. What don't you like? You got too many parentheses? Yeah. There we go. And that one, because it's actually a pandas frame, isn't going to do that. So let's go back. Let's keep what we had. There we go. Let's close that one. Aha, see, AI lied to us. There is no such thing as min-max.
That's funny.
No
So,
attribute of the object.
yeah, so let's do it the right way, or at least the way we know how to do it, which is 0 and -1, right? Now that I know will work because we're pulling a list and we got it. Yay! Now, what's the problem with some of these looking graphs? And that'll be the last thing that we'll leave today. We won't fix it, but we'll leave our code here. If you look at these graphs, what happens? We're always starting at the very bottom and we're always hitting the very top, right? So we should probably fluctuate these numbers a little bit to maybe add some kind of buffer in there, like say +10. And actually it'd be -10, right? On the minimum, and something like +10 for the top part. Now you can see we get this nice little buffer in here and we got some decent looking charts. But we still have a problem with technically starting at 0 unless we label it as 10 trading days ago. And we should have a total of 10 data points here. Right? And we can set that finite number over here. So for this x-axis, instead of 0 to 10, we could actually specify I want 0, 1, 2, 3, 4, all the way through. So for now, before we end, let's go to our commit. Let's go to our main changes, and we could say base structure or base program setup need to clean up graphs. Now, honestly, we should have been doing some commits and pushes along the way, right? We shouldn't have went that far with it. But I wanted to kind of get you through here because we're definitely past the time. Always come out here, make sure it pushed, and it's a good rule of thumb to come back out here to GitHub and refresh and make sure that your code is actually showing up out here. All right. Now, we still have lots of tweaks to do. We got to save them in the charts file. We got to do a README file. We still got a lot to get done on Thursday. All right. Go ahead. You guys got any other questions?
I got a question, Jason, regarding the interpreter part. We explained. Could you explain why do we need to create an interpreter for every project?
Yeah, so the idea there is when you create an interpreter for every project, if I pip install Y-Finance in this project, if I don't create a different virtual environment, then what's going to happen is when you get to the next project, then Y-Finance is also a part of that project. And pretty soon you'll get packages stumbling on one another. By having your own interpreter down here, it's setting up its own virtual environment so that when I run that pip freeze and get my requirements out, those are only the requirements for this particular project.
Yeah.
And like I said, the idea here behind that requirements file is that I can always recreate your exact project because this is telling me specifically what version. And it can be literally from a Tuesday to a Thursday that these numbers change and completely break your project. As a matter of fact, the first year I taught this, we were teaching this exact part, matplotlib. And matplotlib had a bug in the new release that just came out. So students that waited to do their homework till Thursday had the new version of matplotlib and it was broke and wouldn't follow along and wouldn't work with the class project. Even when they were using my code, it wouldn't work because matplotlib package was broke. They had to actually revert back to an older version. So it's important that you always put your package in here so that it always works.
What version of matplotlib are you using right now?
3.10.6. You should be okay within the same day, but for whatever reason, it was weird because it was 2 days later and these guys were all failing and we couldn't figure out why. And sure enough, matplotlib had a bug in it that kept it from crashing. It wouldn't generate graphs anymore, or kept it from running, I should say. All right. Anybody else got any other questions?
Jason, I got a question about the quiz that we need to do this week.
Yes.
The way that's set up, can you like talk about the format? Is it multiple choice, essay? What? And can we go back and forth? Like, can I backtrack? I know some of the quizzes I've taken through Hayes have been just once you answer it, you're done. You can't go back to it.
Oh, I don't remember. Let me pause the recording real quick.
Okay.
The sci-fi stuff that we learned today.
Yes. Yes. So again, the quizzes, as far as I'm concerned, are open book, open note. So you can pull up all those documentation pages and then take your quiz. And if you got to go bounce to find the answer, I'm okay with that. The whole idea is that you know where to look up and find these answers, right? That's actually the purpose of all these quizzes, is that if you don't know the answer, that's fine. Where do you go to look it up? And not ChatGPT. Like, go find it in the documentation, because it's not going to give you answers elsewhere.
And do we need to do this all in one setting? Can we save it and come back to it?
It looks like
Yeah, like
it's
a 60
set for 60 minutes with the required submission. You're really testing my Blackboard skills here. Used to be really easy, but I don't see where I can adjust whether you can close and come back. I know that used to be a thing.
I just like to know what I'm getting into before I.
Oh yeah, you're totally fine. Not a problem. Like I said, the way I used to do it is different than what.
I have one quiz that I have to take that, like, once you answer, you can't backtrack. And in my opinion, that's fine if you're like preparing someone for a certification test like that.
Right.
But if you're not, you're just making the test harder for no reason.
Well, I'll come back to that in a second. Anybody else have any other questions?
Yeah, so do we need to go back and learn about any particular math for this class, or
No.
whatever we know?
No.
The basic math should do.
Yeah, if you can add, subtract, you should be good.
Cool.
Yeah, the other stuff's in there because I'll be honest, I do have some data, data scientists or comp sci students in here that like to crunch data, or they're taking this class because they're trying to crunch data for research. In that case, you may have to do some fangled math in here, but that's why I'm introducing you to NumPy and SciPy to handle that heavy math lifting for you. So. All right, I'll stop the recording. We'll see you guys on Thursday.
What book was it that we used in 360 again?